Okay, so now this system has a 6 drive, but we can't see all of them here, right? Because these are the raw disks. Somebody just added there, and then it's just sitting to be utilized. So when I type F disk, it's only the SDA is showing up here. So what I wanted to show is, sorry, I'm in a different location today, so I'm not using my original computer. But anyway, here. So the very first disk, you know how Linux work on the file system and folder system, right? So all the all the disks are in DEV. So what is dev folder? Let's go back here. Let's go back here and go to our notes. Okay, so the dev folder right here, this one, DEV. Dev folder, it says it contains all the device information. So let's go in there. Okay, so when it says device information, it doesn't mean it's only the physical devices. It means it has a information about the virtual devices too. Okay, so let's take a look here. Okay, we could identify this one as a CD-ROM. Okay, and then it has some information about RAM 1, RAM 2. I mean, you'd be surprised, you've been working as a Linux system admin, but you still be coming across new stuff because you could never be able to work in like all the spaces that the operating system performs on. Okay, so here's the one here. The very first device when it comes to hard drive, it would stand with SD and then A. Okay, very first device is going to be SDA. This is equal to a C drive. So in a C drive, why is it going to C drive? Because A drive used to be a floppy drive, B drive used to be another, B drive used to be a hard disk, remember? And then C drive end up being the operating system drive. Okay, so this is how you compare with. Now the very second drive, when you attach a second drive, it will become, what, can somebody guess what it will become? SDB. Third one, dev slash SDC. It will become it will go all the way down to dev slash SDZ. Okay. Once the Z is done, it will come back up again. If you have more drives, you have like when it's up to Z, it's almost 26 drives, right? When you add the 27th drive, it will become SDAA, and then it will become dev SDA SDAB. So it will go on here. You'll be surprised. Some of the system will have like 200 drives. I've seen it because all these days it's all about data. Everybody is saving so much data on the electronic devices. It's not enough. Back in the day, I used to have like 144 megabytes of a floppy disk. It could hold up to 60 pictures. This is back in 1999. Now, it won't even hold like one picture. To hold one picture, you need like 10, 15 MB to hold like a single picture. You see now? So that if the size is increasing, if somebody is creating like, about if they have a wedding and they snap like 20 pictures, and all of a sudden it used to be one floppy disk. Now, you could imagine if somebody, one 15 megabytes, so it's going to be almost 10 floppies. Okay, so don't be surprised when this hard disk keep going up and up and up because the people in the world are there, and there are billions of people and billions petabytes of data is being created every day, every day. All this is going into big corporations, uh, Google, Apple, Amazon. They are holding on to your data for future use. I don't know what they're gonna use, but they will have it. And then for that data, they have multiple copies. So you could easily imagine it's multiplying, and then that's where you come in, Linux admin, because Linux is being very robust and very reliable. And then you should, if you end up getting a Linux admin job, you should have a job for the rest of your life. Okay, back to our topic here. So we added 6 drives, right? They are sitting right here. SBD, SDB. A is reserved for very first drive. Can somebody take a guess here? SDA1 and B, what are those? Those are partitions. Those are like, these two are part of SDA. These are like partitions. Partitions means if you have like an open hall, those are like you could make some, make a partition and make like stand up walls. You could make walls in there and then make like 2 rooms in there. So imagine SDA being like a big open space, and then you created like a room one, room two, and you refer those rooms as partitions. And in functionality, they work as independent drives. They would be considered one drive. This would be considered 2 drives. Okay. So now we use df, right? Now when you do -h, it will give you more information. Let's compare these two. What H stands for is human readable. Okay. So this one, dev mapper root, this is a root file system. It's all on one SDA, but it has like it call itself root. When you see whatever this would be, and at the end you see root, that means it's an operating system drive. If this this drive fails, then the whole system is down. The data will still be there, but the whole system will be down. That means you have to reinstall the operating system. I've seen it many times. So all you have to do is just re-kick the process, and it will reinstall operating system. I'm sure you guys have done it, right? In Windows, the system crash, you have to reinstall it. But if you have any data sitting on the SDA drive, more than likely, if you don't have other options, if you just run the operating system on it, it will recreate the file system and all the data will be gone. That's why most of the data is being saved on the additional drives which are attached. Yeah. Okay, but we are running the commands here, and the disk we added are not utilized. They're just sitting there. All right, so we're gonna use some commands to make them available to the system. Okay. Any questions so far? Bashar,
Yes.
you have any questions?
No, fine, but I just want to know, like, what the benefit of this? Like, now, okay, we get all this data, how it will help us with the scripting?
Oh, no, 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 no. You're getting confused here. I mean, what do you mean benefit? You
I
have
mean, you
this.
said you said we're gonna continue with the scripting.
Yeah, we're gonna continue scripting as side by side. Side by side, I'm gonna cover other topics. Then you could relate how could use how you could use scripting to get this task done.
Okay.
Did you get it?
Okay.
So don't worry about scripting. Scripting is a huge topic, but I introduce a little bit of scripting at this moment because you have understood so many commands so far. You understood these commands, right?
Yeah, yeah.
So what I thought was it was a good time to introduce scripting. That way you could realize, okay, you could use multiple commands. You could use multiple commands. You don't have to sit there and be using single commands. You could use multiple commands and put it in a file and let the file run it automatically and take care of these things for you. So the reason I introduce scripting at this moment is maybe you could just learn one command and have fun with it and put it in a file and then see what it does for you.
Okay.
So now what we're going to do is we want to go ahead and utilize the file. We're going to go ahead and utilize SDB, very first disk, additional disk we have in there. So to do that, we type fdisk. Okay. So when you type fdisk, you have all these options in here, and you just type simple fdisk, but you didn't give a command to do fdisk on what. So fdisk is a very old file utility built in from Unix. It's coming. It's one of the original disks. It has got its updates, but we still use fdisk. Okay, and then you do option B. You could read about it, what it's going to do, and all that. So what we do is fdisk -L. Okay, when you type fdisk -L, you will get all these listings of the disk here. Let's see here. Okay, I type fdisk -L, and it has the device information here. This is the very first device, and the first device has two partitions. partition 1 and partition 2. So very first device SDA is a boot partition. Okay, so it's telling you disk SDA, and it has the size. Size is 8 gigs, and it gives you a lot of information here. How many heads it has, how many sectors it has, how many cylinders, and all that. Okay, and then moving on to SDB. So SDB, it doesn't have, it's just giving you this information here. It doesn't have this information because this is still a raw disk. So what we're going to do is we're going to go ahead and try to make that disk available. So to do that, we have to copy this, and then you type fdisk, and then type /dev/sdb. Okay. There is one more command. I think you could utilize it to see what partitions are available and what disks are available. You could do cat proc partitions. So when you run this command cat proc partitions, let's see what proc is. Let's go back in here, and proc, it contains all the memory information. So right now the memory has loaded the information of all these devices. So now when you see like SDB, and if it doesn't even have like a single partition in it, that means it's a raw disk. It's still a raw disk. So let's type a command here, /dev/sdb. Okay, and we are into the we are into using sdisk utility, and we are working on the disk SDB. All right. So now, the moment you type this command fdisk, and it's you telling to work on SDB, it gives you here, and then there is a little command. You are into utility, and it's telling you what you want to do. So most of the time, if you're not sure what you want to do, is just type little m here and hit enter, and it will give you these options here. It will tell you toggle a boot flag, edit, and you have all this here. So what we're going to do is we're going to use P to select the partition information. So when you come in here and you don't know if the disk has partitions or not, you should always run this command first. So type P and hit enter, and then it gives you this information here. You have seen that information above here. It's the same exact information. This is giving you information about the SDA drive, and it has other attributes here because this is being used. So it came up this information again, but it doesn't have boot device information. See, under boot device is blank, under start is blank. Let me open another session here. Okay. So since A is already being used, it has to be formatted, and it has to have partitions in it. So let's go ahead and make the partitions for SDB. Okay, so what are our options here? So let's see, create a partition. Which one is it? Right here. Letter N, it says add a new partition. So what you're gonna have to do at this moment is select N and hit enter. Okay. So now it gives you secondary option built into the that command here N. So it's telling you we have an option to create either a primary partition or we could create an extended partition. Primary partition is the main partition of the drive, and then you could have up to four, and after that it will automatically be extended partition. Okay, so most of the time we will be using primary partition. So to select primary partition, just simply type P and hit enter. So it will automatically take number one here. So when this will be ready, let's look at this here. This is a primary partition, SDA, and then the number is number one. Okay. If you come back here and create a second one, it will automatically take number two. Go ahead and hit enter. And then, okay, it's telling you a partition number 1 to 4. So it's hit enter 1 and hit enter. And then it's telling you how many cylinders you want to use. Okay. The default is 1044. So we're just gonna use the default, and then we just hit enter there. You don't have to push one in there. Okay, it automatically took these many cylinders in there. These are default cylinders. Okay, let's see what it says. It says last cylinder plus cylinders or all this. Yeah, so okay, so now it's telling us the default is 1044, so it's kind of confirming here. So hit enter again. All right, using the default value. Now it has done its deed, and what we have to do is we have to select P again to see or display the partition information and see if it has created one. Okay, now, okay, look for SDB here, right? It hasn't created over here. It doesn't have any information. All it has is this information. Now it has created. Remember, we were looking at under boot device. It named it as SDB1 official. This one partition disk. So it's using the whole disk drive as a partition. And the very first sector is 1, and the ending sector is 1044. Okay, and it's telling us in blocks. So all these things are in bytes, I suppose. So all this would amount to 8 gigs, 8 gigabytes. And the default ID for this type of partition is 83. Okay, 83, and then the system is Linux. So let's go here and type that command again, fdisk-l, and then let's look at SDB. Okay, we ran this command again, but we don't see this information here. The reason we don't see this information here is we have not saved this yet. What we have not done is we have not saved this yet. Okay, so let's see here. Okay, before that, let's go into the help menu again, and then I want to see, it gave us the ID 83, right? I want to go ahead and look into deeper what ID 83 exactly means. So for that, let's see which option I'm going to select. Q to print partition table. Print this menu. Right table, verify, change. Let's display entry units. Change partition. Print. Okay, let's use U and see what happens. No, I'm not looking for U here. Right table, verify partition table. Okay, here, sorry, this one. Letter T. Change a partition system's ID. Okay, it's over here. It automatically gave you 83, but we could come here and then type T and hit enter. Uh, no. Okay, let me see. Okay, it's still 83 here. Right, verify partition table, change the display, create new, quit. Okay, quit. So when you're here and then you think all of a sudden you think like, okay, I'm doing something wrong, you could do quit too. You could quit here, just type Q to quit without saving, okay? You could do that. Display, edit, delete. Okay, here, L, list known partition types. Okay, this is what I want to get at. Okay, you could see how many types of partition file system we have here. All these are file system. So we are using 83. Let's look at 83. 83 is, it's a Linux based. You could definitely use a lot of them here. Chris, you could remember FAT 16, FAT 32 should be somewhere here. I don't see it. These are DOS. And these are like all this file system, they came into being over the years. Not one single person has created this. Over here you see Novell. Novell used to be one big company. They don't exist anymore, but they created some kind of partition system here, and it's being used. The one used by Windows is like NTFS. I don't see it here. Solaris. It's by Sun Microsoft System. They created their own file system, but we're not using it as much here. But we are only concerned about number 83. This is in Linux environment. This is the one which is widely being used. Okay, there is one more. We'll come back later on to use it. There would be a swap. Let me see where swap is. Swap, swap, swap. Anybody see swap in here?
Yeah, it's in the top, uh, in the
Where?
right. Second one.
Okay, yeah. We'll be using this one too. Not yet. I will cover this when we're using the sub. Oh, by the way, NTFS is here. These two NTFS, I'm pretty sure these are designed by Windows. Excuse me. So let's go ahead and see. You push P again, and then okay, wait a minute. Something has changed here. The start says 83 or 63. What was the original one? Okay, see something I messed up, so I don't want to save this. So what I'm gonna do is I'm gonna see what is the option there. Quit, right? Okay. All right. So if I type fdisk again here, no changes has been made. So you see SDB is still there. But now I was just fooling around. Now I'm serious. So let's see. I'm gonna print partition table P, and you see it has not saved the changes, so it's still blank here. I'm gonna keep going into menu here. What do I want to do? I want to create a new partition. So there would be letter N. Add a new partition. You do N, enter, and then which one you want to do? Primary. You most of the time you just hit enter. Oh, okay. P, and then the default is one. Enter. Oh, I thought this will automatically takes it as default, but it's not apparently. Okay, this one should take it if you just hit enter. It took the default values and then we hit enter. Now, before quitting, we have to write it. So you select W, it will write the partition information and exit. So type W and hit enter. So what it's doing is partition tables has been altered. So it's taking its time to do it. All right, so let's see if it has written the partition information here. Okay. You notice earlier it didn't have any information here, but now it did. Slash SDB1. And then there is one other way you could check is cat slash proc slash partition. And then you come here, this information will always be there, okay? SDB. And then SDB1 is a partition. It's not like a partial partition, it's a full partition of SDB. Okay, because this number and this number are similar because it's used, you could tell it's using the whole thing. Okay, so here, no partitions. So before we could use it, we have to create the file system. Uh, how do I explain file system? File system, uh, I'm debating if I should tell you about file system now or later. Okay, I have I have some information over here. What I have talked earlier, and then you could imagine we already talked about this, and I talked about the partitions, but you could see um, partitions are nothing but like a room. You have like one SDA, SDB, two, three, four, but we took SDB one here. If you try to go create another partition here on SDB, it won't work because you have already used up the entire space. Okay, so these are all this information here. Uh, okay, so once you have done that, there is another command you type parted R, parted hyphen L. Okay, so what it's doing now here is all this information here, the partition information you created for SDL1 is gonna make sure it's all that information is distributed within, or all that information is written into the other folders. I mean, there are some system files and folders that need that information in there. Okay, I'll explain you what the errors are. Let it finish. Okay, so when you type this command here, you could type this command anytime you want. But if there are any information that was left out and it has not been written, it will go ahead and do that. So the reason we did that is we created this newly created this SDB drive, and this drive information has to be distributed across within the system. So what it does, it will take some time to rewrite those. This is the obvious errors. The reason it's bringing this error back to you is because these are the drives sitting there and to be used. These are like, it doesn't have any information on it. It's a raw disk. We just added those disks from the factory. Nothing else is on it. So let's go ahead and run that command again. Let's see what it's going to bring up. It should bring up the same information here. Okay, so you could use parted-l to get some deeper information regarding the disk you're dealing with. Okay, so let's see here. I'm going to compare if it had changed anything here. Okay, it all looks good to me here. All right, now the disk is there, but it's not ready. bf-h, we just typed bf-h and we created a disk, right? It's supposed to be ready here, it's supposed to be showing up here, and it's not being used. Okay, so why is that? The reason being is we have to create a file partition system. To do that, there is a simple command you have to type: mk. Mk stands for make, fs, that means file system, and then ext4. Okay, currently Linux is using ext4. Before it was ext3 and 2 and 1. But right now we are using the very advanced file system. It's called ext4, and then you have to tell which device is that. So you type dev sd dev sbb1. Okay, so we had the disk, we created the partition. Now what we're doing is we are formatting that partition to be able to use with ext file system. Okay, I'll talk more about the file system either today or in the next session. Oh, look at that. It's telling you it's gonna automatically check for any problems every 6 months. Okay, let's take a look here. Okay, so right here it says block size. Block size is 4096 bytes. So if you the what this block size is, if you create a file, if you create a file and 4096 byte is nothing but 4 KB. All right, you remember what kilobytes is, right? KB, KB, kilobytes. So if you create a file which is only one kilobyte, but the disk space still be used as 4 kilobytes. Okay, so let's take a look here. Uh, 3 KB uses 3 blocks. 10 KB uses 3 blocks. No, I'm not about talking about that. So, for example, let's see if it's going to work here. Okay, so we created a file here in file one, and it's not using any size, any disk space, right? It says 0 here, but in fact, it's using 4 kilobytes of disk space. So that's what I want to see here. So if it's going to use 2 kilobytes, 2 kilobytes still be using 4. But if it's a 6 kilobyte, 6 kilobyte, 6 kilobyte file, then it would be using 8 kilobytes. Did you get it? What I'm trying to say here? Anybody has any questions? Okay, no questions. The second important thing we're looking at is inodes. Remember inodes, each file has its own inode number. Okay? When it has its own inode number, what do you mean? Its inode is independent of the disk's file size. So you could create up to 524,288 inodes. It is these are like system generated number. So if you go like a single number over this, it won't create any files onto the system, onto the disk, this particular disk. Which disk we are talking about? SDB. We're talking about SDB.
Like this is the capacity of the disk.
No, not the capacity. Inode is the inode capacity. You could have like one KB file, and you could have like 524,288 1 kilobyte files, and then it may be using only 1 gigabytes of disk space. Okay, the disk is there, but inodes are not there. These inodes are names. You could have so many numbers of files with that many numbers of names in it.
Yeah, yeah, I get you. Like identity, like ID number.
Yes,
Let's say.
the ID number is full and the disk space is independent. That means disk is there, but ID is not there. That means it won't let you create more.
Oh, okay.
Okay, and also there are some restrictions here. If you creating like too many inodes per group, it will stop you at you can't have more than 8,192 inodes per group. Okay, so the highlighted ones are the ones which we normally deal with. The other ones have some other information here, but you barely use those. I mean, if you want to dig deep into it, I mean, I haven't paid too much attention to it, like super blocks and all those things are there. But when it comes to disk, if there is a little problem, if the system is saying there is one little problem, the disk is corrupted or something, can you try to fix it? Most of the time, big corporations, they don't take any risk. They just replace the whole disk. They just put a new one in there. And then don't go on to your employer and ask, oh, can I take those old disk home? Don't even try doing that. Don't do that, because they usually what they do is they keep the old disk and they shred it. They shred it to the pieces, because you never know how much information those disk has. Even I mean, there are some commands that deletes it, but they don't want to take any chances. They would just shred it. Okay, we kind of already talked about inodes here. It contains like owner information, group information. I'm going to skip this part here because we have already talked about it. Okay, so, well, okay, so there is one command here. If you want to see like a file information here, you could do that. You type stack file1, and it's giving you. I think we talked about when we were talking about the inode information, right? The
Yeah, yeah.
and when it was changed and all this.
Yes,
Yeah.
you talk about it.
Okay. Now it says like IO block 4096. That means it's using 4 kilobytes of disk space. And it took this inode number. It's a random generated number. I suppose it's not gonna take it's like 0 1. It's not gonna go up like that. Uh, there is some information about super blocks. I suppose we could talk about super blocks here. Super blocks. This information here. I barely use it, but I have it here written down. So you could use superplugs. It has like info about how many files got created, how many more can be created and used, and free disk in file system. So I'm not sure if it's showing you the correct information here, but this is what it's used for, superblocks. Okay. Don't worry about it. I don't even know why I have it here. Don't worry about that one. So we're gonna talk about this part here, mounting the disk. Okay. So when we type disk, df hyphen h, okay, so you already created disk, but you haven't done the next part. It's called mounting. It's called mounting the disk. So you thought you created a disk and you give this disk to the user and say, okay, everything is ready. He will come in here and see, okay, Well, you said everything is ready, but it's not ready for me. So what you have to do is you have to follow this process here. So what you could do is uh, we could create what how the way the disks work in. Uh, by the way, you could see my whole screen, right?
Yes.
Okay, good. I couldn't find much information here. Let's see. By the way, when you go onto the job and you be googling, putting something in the Google, don't be hesitant to do that, okay? Because everybody is using Google to like go and find information and then use it. I always use Google. Everybody is using Google. I've seen people been there for 25 years and they're using Google like to search around and find something. But like very very careful when you find some command online and then you're putting in here. Check with somebody at your work before you do that because it may seem silly, but it could harm your system because you have a root access. Okay, let's create a folder, Bashar. Let's go into that folder. It's nothing in there, right? So what we're gonna do is we're gonna mount. What it's called is mounting. What mounting means is making the disk available. So how file system work is this this SDA1 is mounted into the folder SD into the folder boot. Okay, so let's go into this here and then see what's in there. Okay, so it has a kernel information in there. So we're not worried about it. Let's go back. So to make the disk SDB1 available, all you have to do is use the mount command. MOUNT. MOUNT slash which which device is that dev slash SDB1 and then where do you want to mount it to? You mount it to Bashar. Okay, the command is mount MOUNT. This is a built-in command. Dev slash SDB1 and then give a space and then you give the name of the folder root slash disk then Bashar and you hit enter. So what it's doing here is it's mounting, it's making this disk available on this folder. So you do ls, it's nothing there, but you type
Like in this case, Zafar, you are giving space for the folder to be booked inside the new disk.
yes.
Okay.
Right here, you mean here?
This command mount mean you are booking space for Bashar folder inside
Exactly.
the new drive, the clean drive.
Exactly. Very good, Bashar. You got it. You got it. What I'm trying to suggest here.
Okay.
Okay. See now, you type dff and h. Previously, it wasn't showing this, right? Now you have this here. So this disk SDB1 and it's 7 gigabytes. It's actually 8 gigabytes, but it's showing you the exact because some of them are being used by system, and then it's being used 8 megabytes. This is how it's going to be. Even in Windows, there is some information, there is some hidden information that the system uses. Because when it says 8 gigabytes of hard drive, that doesn't mean like you're getting 8 gigabytes of hard drive. Just like iPhone, you go out and get an iPhone, it tells you, when you get a brand new iPhone, it's 32 GB. But when you go into the storage, it won't show you exactly 32 GB. It probably will show you 28 GB or something because some of the space is being reserved and is being used by the system. So, and then you have this much of space here. The important thing is all these are not exact information. It's never going to be exact information, okay? Because this is just a general information. And then it's available on this folder here. So let's create something called, let's create about 10 files.
But Zafar, before when you used to create the folder, we don't do this before. Like
Exactly.
the
Very good.
system, the system was taking this direct. Why now you are just redirecting to the new drive? Like the main idea is just you want to redirect this to the new hard disk, the new device, the, the new driver.
Yeah. Anything you're going to create in this folder, moving forward is going to go in here. Okay? That's how Linux works. This folder is a window to this disk space. Okay, so let's see if you could go in here. Okay, let's do file, touch file. We have done this, right? The for information to create like multiple files together.
Yes,
Okay, what was it?
you have to open like bracket. So
Okay, Huh. I think I have. So, what was the command? Do you remember? Hmm. For I in. But anyway, here let's create about 10 files here. Okay. Touch file one. Okay, we have about 5 files. In where? In the folder Bashar. Okay. Then those files are also being used on this disk here. Let's see if we could go in there. CD LSTD1. Okay, so I thought I'm not sure why we are not able to go in there, but I will get back to you on this error message why we're not getting it. But anyway, what it is this disk, this information, and this 5 files are sitting in this disk here, and we're using the window, also a folder name Bashar, to go using the. We are writing to this folder here, but its essence is sitting in here. So let's unmount it. There is a command called umount. There is a command we used mount, right? Mount to put this on it. What we could do is you could do umount, and then you give the name of the folder. Root is, you hit enter, and then you type bffnh, and it's gone. You see this?
Yeah, now it's not in this disk.
Okay. So what will happen if I type ls?
It will go to the root.
No, still be in there. Now, what we're gonna do is we're gonna restart the system here.
It will show you just now, but when you restart, you will lose it. Yes.
Yes.
Okay.
Use it. That's what it's supposed to be. Okay, because right now it's in the memory. Let's restart the system.
Does he call it Zafar the temporary memory, or
Say it again.
like why it's still showing? Because it showed in the temporary
Yeah,
memory.
memory. Yeah. taking its time. I don't know why it's taking so long. I'm not sure why is it taking so long. It has enough RAM here.
Hey, do you think maybe the two putty windows open?
Huh? I'm sorry?
Hassan, do you think maybe it's the two putty windows open? Possibly.
No, I have many. Party. Let me close this one. It's here. The virtual box is. It should come up now because it's maybe the IP address has changed. Oh, come on.
That is the error message I'll get when the IP address did change. So
Yeah, that's what I'm thinking. So I have to wait for this to load and find out the new IP address. Yeah, definitely the IP address change. Come on. Yeah, I miss my other computer here. So are you still getting the IP address being changed? So you're going there each time and have to check the IP address again? Is that what's happening?
I have to do it every time. Yes.
It's killing our time. Come on. I don't know why it's taking so long.
Hey, I could be wrong, but when you're launching VMbox, don't you have to interrupt the boot process? Select run level 3 and then hit boot or hit B.
Yeah,
Because usually when I get to that window, that means that I'm in like the virtual Windows or whatever, and it doesn't. I can't actually access anything with command line.
yeah, I let it pass. I'll interrupt this time. Mm. I'm sorry, why is it? I don't know why is it taking so long. Shouldn't have rebooted it. It came up just fine when I started it first time. It's using only 3 GB. Ah, this may be a problem. It shouldn't be using 100% of activity. You know what I mean? Come on. Bashar, can you share your screen? Do you bring that up, bring it up, and then share your screen.
They asked me to download something here.
Um, are
I
you in a
have,
browser?
I have to go to share contact.
You know what? Just give me the TeamViewer information. Let's connect with TeamViewer.
My name, you mean?
On the TeamViewer, launch TeamViewer. Remember you installed TeamViewer, right?
Okay.
Yeah, launch TeamViewer and give you your ID and password.
Yeah, I have it. Just 1 minute. It's 1326
Okay.
993 263. This is the ID.
Okay, it's not working, but okay, maybe it came up here. Here, give me 1 second.
Okay.
Okay. So we even ran the um, we unmounted it, right? So let's see why it is still showing us the files are still there. So let's see here. Uh, Remount or maybe mount. Okay, so so I think that what I'm trying to show is not working here. Let me create a new folder again, okay? Uh, Let me create one slash mnt. Mount slash dev slash sbb1 then slash char 1 df hyphen h. It's there. So let's go into cd. Okay, I got it. So what was happening, Bashar, when we were unmounting it, we were being in the same drive, same folder. So when you have unmounted, you have to get out of that folder, and then you have to U-mount it. So I'm gonna show it from the scratch again. Okay?
Yeah, you go to the root, then you do unmount.
Yeah.
Okay.
Very good. You understood it. So let's create a folder here. MK. So we do df-h, right? We don't see HDB1 in there. So to get it utilized, SDB1, what you have to do is you have to mount it to the folder. So what you do is let's create a folder mkdir slash uh, slash Facebook. No, I don't like Facebook.
Zafar.
Data data slash uh, data slash data one. Just like Oracle. Okay. Oh, can somebody explain me why am I getting this error? Do you get it?
Yeah, because you make it as a tree directory.
Yeah. So you need hyphen p.
Yeah.
So I'm gonna mount it. Mount slash dev slash sdb1, which is the drive we're gonna use. Then we're gonna mount it to data
Oracle.
Oracle. Okay, it's mounted here. So let's go into this folder here, cd/data/oracle, and hit enter, and let's do ls. Remember, I created about 100 files in here. So the 100 files are in this folder. So let me go ahead and remove it. So let me go ahead and create 100 files here. Touch, data. So we got about 1,000 file in here, right? So we are in the file name data/oracle. So let me get out of here and then type df-h. Okay, so let me unmount this disk. Umount /dev/sdb1. Okay, and hit enter. df-h. Okay, this disk is not there anymore. It's not available anymore. But let's go ahead and go into this folder and see what we could see in there. Okay, nothing is in there. We just created about 1,000 files in this folder, but where this files has gone? It is, we indeed created in this folder here, right? But it is sitting actually in this disk. So what happens most of the time is somehow this gets lost here. So if the data is empty, you don't have to worry about it. You have to find out where data was sitting originally. So let's create another folder, mkdir hyphen, you don't have to data 1. And then I'm going to mount this to I'm going to mount SDB to the data 1 folder. Okay. Simple command is mount dev sdb1 / data 1. Okay. Let me hit enter. So let's go into this folder data 1, and we should expect 1,000 files in there. There you go. So what's happening is if the operating system drive fails, okay, if the operating system drive fails, all these folders are in an operating system. That means on Linux, right? I'm doing this on I'm on a root here. So all these things are sitting on a root, and any folder you create is being created here on the root file system. So if the drive fails, okay, so there is some information connected. The folder is associated with this drive, So for us to make sure the data is not lost, because some kind of association is there, data won't get corrupt, we use this system here. So if this folder dies, doesn't matter. The data is there. The data is available here. And then we could use this drive and literally mount to any folder. Literally any folder. And then we could even mount it to the some of the existing file. Yeah, we could see if we could mount to Bashar. So you mount. Okay, and then there is nothing in there. So let's go to the folder. We have one folder in here, right? CD disk for sure. All right, so we have this folder with all these files here, right? What we're gonna do is we're gonna try use this folder to mount the disk. So let's do cd mount /dev /sdb1, and then I'm gonna mount it to the file here. What will happen to these files that are existing in here? Okay, the files that are existing here is not being read. The files are still there, but it's not being read because at this moment that folder is being utilized for SDB1. So remember we had it, we could literally take this, and then mount it to any folder we want. Okay? So let's go here, go back here, and then let's U mount it. U mount dev, and then let's go back into this folder again. What's the command to go back to the previous folder we were in? cd hyphen. So it should put us in the original folder. When we do ls, see the original files are back in there. It's pretty confusing, right? So next week I'm gonna go over this a little bit more, and then we're gonna manipulate, and we're gonna add like a couple more drives in here, and then we'll see how all these things will play out. Okay, because we added how many? We have like 6 drives in here, right? So we just played around with one, and we have 4 more. So next week I'm gonna go ahead and next week I'll present it very good, and then we will work on it. And then these things are very very important. These are like these things you will spend a lot of times in here. So I will make sure you have get the concept very good, and I will go through this, and then I'll go through this document and see if I need to tweak this document before you could start practicing on it. Okay. Any questions? Okay,
No, thank you.
yeah. All right, I'm gonna go ahead and stop now, and then download the video and then upload it within a couple hours. Okay.
Hey, excuse me, didn't you say you're gonna provide us a link to a test or something?
Yeah.
That's so.
Actually, I'm in Chicago right now, so I'll work on it. I just came back last night, so we'll see how
Okay.
it come out. But
All
I'll
right.
definitely give you a test this week, and then you could work on your own, and then own time. It's open book. You could go and look around all those things, and then I think I have most of the tests ready. I need to add a couple more things before I send it out.
Cool. Thank you.
Okay, sure. All right. Thanks for joining, everybody. Have a good one.